Hey everyone, welcome to Matrices. This video is going to have the basics, what you need for the big ideas, Cengage Learning Textbook 1.7. But this is going to be the add and subtract matrices and multiply by a scalar. That's all you absolutely have to know for Oklahoma standards. However, we are going to do some matrix times matrix in the next video. So let me minimize that. Here we go. This is our matrix. This is not our matrix. Haha, funny joke there. But a matrix does look like this, where you have a certain number of rows and columns, and that's how you get your dimension. And I'm probably going to go really, really fast here. This was a fairly easy concept for mine to understand, my students to understand. So to get your dimension, it's rows by columns. So 2 rows and 2 columns is a 2 by 2. If it had 3 columns, it'd be a 2 by 3, or whatever it is. Corresponding elements basically mean they are sitting in the same spot but in 2 different matrices. So A and E are corresponding corresponding elements. B and F are corresponding. C and G, D and H. So multiple choice might say, well, which of these 4 are not corresponding elements? And it would be A and H because they're in different spots. Corresponding elements work the same way if the dimensions are not 2 by 2. Yeah, they have a spot in the others. Now, when I'll get to it, but must have same dimensions. In order to add or subtract, they got to be the same, because you don't want to have like an extra something here that doesn't have an extra something here. And like if you try to do 5 plus in your calculator and then hit enter, it's going to pop back an error. Like, hey, you can't do this. You can't just do 5 plus. So anyway, this hopefully looks familiar. You just do the corresponding elements and add them together. So A plus E, put it over here, and then turn it into an actual number. Subtraction works the same way. A minus E, put it over here, same way. So it looks a little bit like this. And I told my kids, yeah, you could probably go from here straight to the answer, but this is how you show your work. So 9 plus 7, put it here, then give me an answer. -1 plus 0, put it here, then give me an answer. They understood that pretty well. Subtract was the same way. Just got to be careful with like double negatives and stuff. Use your calculator if you're not sure. But 2 minus -3. 9 minus -9. This is not 0, it's 18, because the double negative actually means add. Same thing here. We all have corresponding elements, so we're good. And I didn't show work here because I had them do it, and I just asked for the answer, which was correct. What happens if we have different dimensions, though? A has a corresponding element, B has a corresponding element, C does not. So we cannot add or subtract. This is the 5 plus, oh, there's nothing here. Can't do it, so we'll just leave it as is. And again, I'm going real fast, but pause if you need to. Same thing here. This is a 2 by 3. This is a 3 by 2. These are not the same, because C should have an element here. L and M should have elements down here. And everyone's like, well, you could rotate it. Okay, well, are you going to do A and G and B and J and C and L? Or are you going to like legitimately rotate and go A and H and B and K and C and N? Like, how are you going to do? And those what ifs and how are you going to do it kind of things are the reasons why we just don't combine these. Even these, the 3 by 1 and 1 by 3, you're like, oh, well, A goes with D and B goes with E and C goes with F. It's simple, except it doesn't. So just be careful with these different dimensions. Multiplying by a scalar is basically distributing to everything inside the matrix. So here's matrix R, A, B, C, D, E, F. Find 3R. Well, I'm just going to take a 3 and distribute it to everything. Perhaps they give you matrix S. This does not get the 3 because 3 goes with matrix R. If I wanted to change S, I would have said find something S. So it's just distributing. Looks like this. Here's T. Find -2T. When you distribute -2 to everything, you get this matrix. Now, it's important that you label it -2T because this is no longer T. This is T that got changed. So make sure you label it correctly. Here's the last one I showed them with add, subtract, and scalar. It was a combination of the both. Here's A and B, and find -4B minus 5A. Well, -4 times B, put it there. And then we had a dilemma. We could either do -5 times A and put it here, or +5 times A and put it here. And let me tell you what I'm talking about. There we go. If you choose positive 5a, then leave the subtract out here, and when you do a minus 5, whatever, the minus shows up here, okay? If you choose to use a negative 5 to distribute, and it'll give everything a negative, make sure you add out here. That way it's still plus a negative, and it shows up as subtract. It operates the same. So we chose to do this down here at the bottom. Either way works. Either put your subtract, your negative with it, and all of them get it, and that's how it'll show up. Or leave the negative out here and just use the positive number and then let the subtraction. Either way works. We chose to go with the positive 5 and leave the subtract out here. Positive 5, and now I subtract matrices, and again, I label it not, here's just my answer, it's here's negative 4b minus 5a. I took two matrices and combined them to one matrix. You got to tell me what happened. So you can't just go equals this and be done. Make sure you give it some sort of label. But that was it for add and subtract matrices. Like I said, multiplying matrix times matrix will be on the next video. My kids are going to have to know it, but Oklahoma Standards does not technically have you know that. But it's not too bad. So we're going to learn it.